Hello and a very warm welcome. Today we're going to look at evolutionary architecture, and I'm here with Mike. Mike, what the hell are we going to talk about?
Hi, Johannes. Thanks for having me. We will talk about evolutionary architecture and how this helps moving decisions to later phases of the project and being able to pivot in another direction at any time.
And obviously, as this is a CI/CD channel, we are also going to look at the CI/CD portion of it and how actually you need to adapt your CI/CD pipeline if you change your architecture. So I hope that you're going to enjoy, and I look forward to your feedback in the comments. And if you really like this kind of sessions, please let us know. If you didn't like it, please also let us know so we can then improve building from that thing. But before we go into the topic, Mike, we recently met in Hamburg when at the AWS Summit, if I remember correctly, but we have been in contact for quite some time. So tell us a little bit about yourself and what the hell you actually do.
Yeah, so I like to start often the conversation with I exchanged source code for food the first time 1999. So I'm doing that now for quite a while. I think I have seen nearly every position from coding to team lead to project lead and then back. And then I decided that freelancing is what I want to do, so get my hands dirty, actual work, right? And while freelancing, I met my now colleague Stefan. We decided then how we want to do work from now on, or better, how we don't want to. And basically what we're doing is building serverless first applications now since 2016. Don't want to go back anymore. And that's also where we adapted early the whole idea of evolutionary architecture. So this is, of course, not our idea. And the patterns for that. And we had quite some challenges in the last 9 years, and we were basically able to solve all of them.
Cool, that sounds pretty interesting. It sounds also like you have a lot of experience in this field, and I think that's what we want to hear. What is your experiences with evolutionary? What's your experiences on when do you need to adapt from a plain serverless application to something that maybe is not just plain serverless anymore? Because most of the people that consume this part of the content are hyped because of serverless, and we've heard a lot about that in the last 1 or 2 years. So why should you go out of that?
So first, I think you need to get a step back and look at the whole serverless idea again. It looks like everything is there, everything just works. But in the end, there is, of course, servers underneath it, right? And for example, I see Lambda is a Docker container on steroids. And that is how you should treat it. It's not like something magically, everything that you can do in Docker, you will do there. Some is managed, some is already taken care of you, some is biased, opinionated, basically. And often it fits. So that's also why we say serverless first. We start with a serverless approach, and when we see that it does not fit anymore, then we go away. And one thing I seldom hear is that the architecture does not need to fit the actual business requirements and technical requirements. The architecture also needs to fit the capabilities of the team. So if I have a really mature team that is really good at doing Kubernetes and they are really mature at that, why should they do serverless if they do the same thing? And maybe cost is not an issue, or in some scenarios, Kubernetes can be the most cost-effective solution.
Yeah, that's true. And I think there was a prominent example, I think last year or the year before last, where Prime Video announced some changes as well, where they moved away from actually using serverless and using Lambda, right?
Yeah. I think they did some video processing with step functions and then found out that it's not scaling as they liked it to be. And then they moved back from the step functions part and moved that to ECS. And they claim they saved up to 90% of the cost by doing that.
Cool. Yeah, that sounds like something that everyone wants to do at the end, right? So I think that article got a lot of noise, and it's funny it's not available, or at least we didn't find it anymore on the Prime Video tech site, but we found it in the Internet Archive. We will link the link to that in the show notes. I think it was a very well and much discussed and also much misunderstood article at that time. But I would also say it shows that you always need to look at the architecture that you use for your software and for your products that you actually build, right? So you really need to decide when it is time to move on from where you are today, because it can have a big impact on what you actually deliver to your customers. And I think this brings us to the idea of iterative architecture and evolutionary architecture. What are the most important things that you believe people need to understand if we talk about this topic, Maik?
So first of all, I would say simplicity is key. That's important. You want a easy to change, easy to test architecture. And also with abstractions, you want to find the perfect spot for them, so that they are not all over the place, but they are at specific places where they actually have meaning. And the other thing is, don't ask if change will happen, ask when change will happen. And also while architecturing, ask yourself not, but what if we need X and Y later? Just think about when I need to change it or something in the system, what would be the most painful? That is the thinking process to mitigate the effects of change in the future. And then you go as simple as possible. Like if you know the TDD cycle, it's the same, right? You build your test, you write what is needed, you make it pretty, and only if you need it, you make it fast, and then you move on until you need it differently. And you just zoom out and look like that at your architecture. You build what you need, then you make it maintainable if it works, and then if you need, you make it fast. And yeah, for us, the go-to architecture or the go-to approach is ports and adapters, where you basically encapsulate your business core logic in the middle. And that also pairs well with DDD, of course, because your core service code should actually be readable by business folks, because you see all the concepts, all the name again, and it interlinks really, really well. And then you just move all the details to the outside where it's easily changeable.
Okay, that makes sense. And in the context of evolutionary things, I think one of the most famous thing that people that are close to the AWS world of developing things talk about is the idea of one-way versus two-way doors. Let me try to explain what it actually means, and I can talk a little bit about that. And I think that's pretty important, right? So AWS, when they develop, they talk about the concept of one-way versus two-way doors. One-way doors are decisions that are so fundamental that taking a different path later is a big problem. Two-way doors are things that you can revert. That means you revert without a lot of costs. That means what I think that evolutionary architectures need to keep in mind is that you always need to identify decisions based on one-way or two-way doors and then assess the impact of those decisions. As an example, you just mentioned that example already. You talked about, okay, we usually start with serverless and then we move away. And in the next few minutes, we're going to look at where do you move away. You already hinted at that because you said Lambda is a container on steroids for me. So choosing Lambda initially gives you a managed container runtime that you can actually use. If you then decide you want to move ahead to something else, then there is options. And that's a two-way door, right? You can move away from Lambda if you want to. And that's the concept that I think we need to apply as well. If we start building out architectures, we need to identify those one-way doors versus those two-way doors. Because the one-way doors are the ones that are going to hurt us, where maybe everyone in the team needs to be involved. The two-way doors are ones that Maik or Johannes can take alone without consulting with others, because reverting that decision and going a different direction is simple. And that's the concept. And I think that's what you kind of actually said. But I wanted to bring up the term because it's very AWS native.
Okay, yeah, I never heard that.
There's a good one. There's a good book around that. I don't know. There's I will find the book name where someone explains how AWS was created initially. It's a very interesting read. I will try to dig it up and send it to you later.
Oh, okay. Yeah, that sounds good. Yeah, I think also one thing to add to that is this change is never free, right? So what you need to make sure is that it is possible and at a reasonable cost. I would say that is the two things you need to have in mind. So again, think about how bad would it be to change the Dynamo against an RDS. So how much impact would that have? Can I do that?
Makes sense. Yeah.
Yeah, just for example.
Cool.
Okay, so
Sorry, let's move on.
So yeah, we prepared a small repo that I actually used to train developer teams of our customers on DDD, hexagonal architecture, and actually changing stuff. And I prepared a small scenario which I would like to introduce first, and then we can go more concrete.
Let's go.
So what we see here is a small picture of a bigger domain. So we have for the scenario a supplier of motors, and they sell motors to their customers. And what they want is they want to store that in the system so they can create a motor and they can assign an organization to a motor, basically their customer. That is the asset domain, the organization domain, and here we have our motor aggregate. So assuming that you already know what aggregates are, that is just a entity concept and a lot of business rules hidden inside here. And also what we want to do, the user should not see the organization at all. That is a concern of assets, not of the user. So when we model that with ports and adapters, we try to have everything that we see in here in the core logic. And also we use the same name. We use motor, device, we use create, motor. We have all the terms again in our code. And you see no detail here. You see no database. You see nothing like HTTP or Lambda or whatsoever, because that is not our business concern, right? That is a technical detail. I think C. Martin calls the business logic policy. And the outer world is detail, and that is also something I like to use. So here we only see policy. And how that could look in a Lambda is as follows. So we have our user, we are in the AWS world here. Of course, we have an API gateway, and we have, let's say, at least one Lambda. Let's start with a Lambda list. We are in the first iteration of this project, the first implementation. So what we do now, we in the core of the hexagonal architecture, we have two services, assets and organization, and we implement the core logic only inside there. There is no code dependency pointing outwards. And in here, there is no concept like Lambda, like SQL, like HTTP, just not happening. And then
But it means that you have a single Lambda that has the whole functionality in both domains in it, right?
Yeah, why not? For now, we start like that.
Okay.
So there is no need for an abstraction, no need for event-driven here. So we might come to this point, but not in the third iteration, right? So the idea is that we start with a monolith here, but we are able to move out what we need to move out later when we actually need it. So we have our Lambda controller, basically connecting our business logic with the detail of what Lambda is. Then we have a persistence, for example, file storage or SQL or DynamoDB. SQL is not part of the asset package, but in persistence you find queries, you find the concept of SQL, you find retries, all what that you need to get to a network attached storage of some kind. And both services are also connected via gateway. So asset does not care about how exactly I call organization, right? It just give me a service gateway, make my call. If it's event-driven, if it's a REST API call, I don't care. I just want the information or my message sent, and that's it. Both have storage attached. So the idea now is that, or let us look into that, right?
Yep, let's go.
Let's look into the code. So here's the repository to give you a quick dive in here. We have our Lambda app, that is our entry point. So we can create a new motor and we can assign an organization. And we have a little bit of static dependency injection put in here. So for the sake of the example, I did not use a fully blown dependency injection framework. I just connected the dots. We have our two Lambda entry points that can also be in one Lambda, that can be deployed to two Lambdas. That's actually up to you. And we also have the opportunity to run that locally. So here I just grab the handlers from the Lambda and run it with a mocked proxy integration event, or at least the part that the Lambda cares about, and then I can run it. So also a good example that if you build Lambda code, you can test 99% of it locally most of the time. You just need to do it. So then we have our services folder, and here we see our asset and organization, like in the picture. And in the asset, we have our core, our business logic, and the adapter where all the detail is hiding. And in the core, we have our entities. So we see here our asset type, we have devices, so like in the picture. And we have our organization. And this organization just is all about the ID and storing the name for convenience, but not the other details of it. Because we are in the asset domain, so we only care about the small part that we actually need. And the organization is the same. Core, adapter, that's it. So how to connect it? We have our service gateway here. And that one knows actually the controller of the organization. So those two are connected. And I have built a dependency graph to make that more visible. I know that is a lot, but let me drive you through this. So we have our asset, the left box. You have our organization, the right box. And in both boxes, we have core and adapter. And one thing to point out, you see dependencies are only inwards, right? So there's not a single arrow pointing from core to adapter or anything other outwards in both services. So we have always one directional dependencies. And the only connection between organization and asset is the service gateway and the service controller. That's it. So if I now want to make the cut, let's go back to the...
What do you mean with the cut?
If I now, the cut of to this one. So now we cut out the organization.
So I think what you're trying to say is like we have now had this one Lambda that has all contents in it, right? And now there is the need to change this a little bit, right? So to ensure that we can decapsule a little bit, right? So I think the main foundation of this is that you have introduced that concept of a core and adapter in services, because that gives you the possibility to draw boundaries that you can then actually use to evolve from where you are, right? And that's the point I think that you need to keep in mind. You need to think about how you build your piece of software to then be able to move away from where you are. So to go back to the AWS terms, if you go back to your code, one of the key decisions, and this was you created a two-way door because you built your source code in a way that you can now see those contextual boundaries. And you can take them and split them apart because you only have this connection in the one connection that you have. And I think that's the key point over here, right? When architecting this, you started with that idea in mind of being able to split things out later. And I think that's the next step that we want to go into now is, okay, we have our first iteration, we have deployed everything, and when we talked as a preparation, you said we deployed everything in a Lambda lid, which is kind of a monolith, right? Everything together.
Exactly.
And now we're moving ahead from there because our the demand for the organization changes potentially. And I think that's what we missed to say, like before we move to the second step, right? Let's think about, okay, now the demand of what the organization needs to do and how the organization function needs to operate in our picture now changes. So there is a need to scale it different, right? So that was the idea. Can you please talk a little bit about that?
Yeah. So the idea is for now, asset is the only consumer of the organization. And that's easy. They basically have the one-on-one association, also what the load pattern says. And now we get maybe some other consumer here. And this consumer now might have a total different load pattern. So maybe there's a lot more load on that and a lot of small requests, which is always a good thing to look at because then Lambda gets pricey really quick. And maybe that's not the best idea anymore to do it like that. And maybe we want to switch organization to an ECS container for that reason. So we don't want to move the whole application. Or let's say it like that, we don't need to move the whole application yet. We could, of course, but we can also say we just move the organization. Another thing is asset and organization grows, and you decide that organization service is so big now that it needs to be tackled by a single team. And this team is way more familiar with containerized workloads and so on. So they said, yeah, can we do it like that? And you say, sure, why not, right? So the question is now, how do we tackle that? I think first thing we need to do is get rid of this direct code connection. That's the first part. And now the question is, what now, right? what we need to do now is to, first of all, get this organization in a container. And then we need 2 new adapters. We basically drop the old direct service adapter with a HTTP gateway. This guy now knows about the concept of HTTP. It knows post, get, authorization. All of that lives inside there. And on the other side now, since we don't have the Lambda handler anymore, we need some kind of application running. That could be some generic HTTP server and a little bit of adapter logic to connect the dots to our organization. In our example, I choose for the client just fetch because it is just there. And for the HTTP server, I built a simple Express app. So that is the most basic HTTP server, I think, in the TypeScript world you can just set up. And then in here, the connection is now not a direct association anymore. The connection is a URL, a port, and maybe a base path. And actually, that's already it, right? It sounds simple, and actually it is. I think this example, and to move it, is roughly 300 lines of additional code. I think that's reasonable cost. And we did not do any change here. We only did additions and deletions, and we did not touch the actual business logic.
Cool. So with that, we get the possibility to move the organizations out to a different type of workload. In the example, I think we've chosen a containerized workload, so Fargate, ECS, or something like that, right?
Exactly.
And that gives us a lot of possibilities. Now, how does this look from a CI/CD pipeline perspective? Or do we want to look at the changes in the code first before we go there?
Oh, we can do that really quick. I have that prepared. So I have a pull request opened. That is in the repository. You will get the link afterwards and can also see the PR. Here we can see what we did actually. We added this Express app, few lines of code. Then we changed a little bit of the dependency injection from the Lambda. So we removed the old direct connection and we introduced a HTTP connection. Important part is that, of course, belongs to a configuration, but for the sake of the example, it is hard-coded. And then in the actual services, you see assets only changes in the adapter folder, organization only changes in the adapter folder. So no core logic tackled, and the same is here. And of course, everything is tested. That's also a big benefit of Hexagon. You can really test everything easily. And if you see here, it's 640 lines of code changes, but the dependency graph update is half of it already. And now with the updated graph, you can see, I hope it is big enough. Here's our old connection between both in the code, and now it's gone. You have the HTTP gateway, you have an HTTP controller, and it's gone. You can even move the whole organization service now out of the repository by just cutting and pasting. And that's it, right? You can leave it in the same. You can have mono-repo approach, or you just cut it out. And I think that is very well covered. That is very well spoken about. Hexagonal architecture is not a new topic. The whole solid principles that help and enforce this is also not new topic. I think the interesting part is now, how can my pipeline evolve with that? So the code change is easy, right? But going from a Lambda deployment to a ECR deployment, that's a different beast. We're now talking VPC, right? We now have security groups that we need to tackle. We have the whole cluster that needs to be, our deployment approaches are different. So there's a lot to change now or to add. Before we go into that, one important point is
there's a timing issue as well, right? So deploying a Lambda is literally fast. Deploying into a container world also changes the deployment time for the CI/CD pipeline a lot, right? So I think that's also something we shouldn't underestimate. So how do you look at the pipeline of the Lambda lid, right? And how do you then evolve that with the new part of the architecture? Let's talk about that.
So we prepared here let's say, a really abstract idea of a pipeline. So we always start with the sourcing step. Then we build our code, we test our code, we somehow package it, and then we deploy it. And once we're done with that, we verify it.
That's a classical approach.
this classical software part, right? Not even infrastructure mentioned here. And for an ECS setup, that's also an example. There are different ways of doing that, a lot actually. For this example, we have two pipelines here. So we have first the source code change is the same. We build, we test, we package, and we build an image. We push it to ECR, and then we deploy it to an existing cluster timing already. And then we verify that our change was good.
To an existing cluster and or to an existing Fargate service, right? I think that
yeah, exactly.
Depends on how you want to deploy that. Actually, we are not even forced to push it to an existing cluster. We could also potentially start with running our container on Lambda if we want to, right? That would be also an option as a first step, right? But I think the containerization gives us the flexibility to now deploy it to either an ECS cluster or an EKS cluster if we ever want to go that way.
Yeah, exactly. And then for this example, we split out the ERC code, and we also have a sourcing step. We do some checks, some testing. Then we apply the changes, we verify it. The good part is when we apply, it will most likely also automatically grab the latest image and deploy and so on. So that works. And that here we have also the concerns separated. So we have the infrastructure concern is a different concern than the actual source code change. And also that speeds things up. It brings other challenges, but it speeds things up. So,
True.
And also, I think the infrastructure change in an ECS setup is not as frequent as going full serverless and adding Lambdas, SQS, SNS for each use case and stuff like that. Yeah, and when we now look at a CDK serverless approach, maybe even with CDK pipelines, we have a little bit of a different setup here. So it is fast. Actually, I like it, but it has its own challenges because the CDK synth step does a lot for you. So if you have Lambda, you can do the build, the packaging, the testing, all inside CDK, all while you do the synth step, because before you go to the next step, all the artifacts need to be there and need to be pushed already. That's the assets. And then even with or without the self-mutate of the pipeline, so let's ignore that for now. Might mean you can also do the CDK serverless pipelining in GitHub Actions and whatsoever with the CDK CLI. But the important part is you deploy code and infra at the same time. So that's the nature of Lambda. You need to specify the code package for the Lambda when you make changes. And you always have to deploy at the same time. And then, of course, you verify. That is fast. For the first iteration, often good enough. But that has challenges. When even when you go to ECS now, then you need to have this step combined with those. If you do it in the same repo still or in the same pipeline. And it gets messy real quick. And there are branches and all that is not really clean. Yeah, and maybe another example from the days before the CDK. How did we do it there? So back in 2016-17, we only had CloudFormation. Good times and a lot of pain memory, but it worked. And there we had a pretty similar setup. So you also, of course, need with every deployment to specify your source code, but you specify it by pointing to an S3 bucket. And that you can also see like pointing to a Docker image, right? Or an ECR image. So what you can do is you can change your source code, build, test, package, all the good stuff. Then you push to S3, and then you can deploy directly to the existing Lambdas. That is one approach. So code build or code deploy can do that for you with canary deployments and awesome stuff. But you can just do it with the AWS CLI. You can do it with Bodo 3 or whatever is your language of choice. And then you verify. And when you have an ERC change, you can check. Then you deploy your infrastructure and still point to the latest working code package on S3. So like the ECS example would grab the latest stable image version, and then you verify. So that is one approach we used to stick close to what we need when we go to ECS. It is not that much harder, still fast pipelines, but developing that, of course, is way slower than just going with CDK serverless, right? Putting it all together. Yeah, that's basically the setups that we use so far. One thing for the pivot, right, is that one is different, that one is different, that one is different. The rest is kind of the same. One approach we did was we did not write any commands, CLI commands in the actual pipeline script. So for one customer, we moved to...
Just wait a second. Before we go into that, I think...
Yeah.
So we've seen that if we change the deployment model, obviously we need to adjust the pipelines. But
exactly.
And now we didn't really talk about which pipelining tool we use. You mentioned code pipeline, you mentioned code deploy. Obviously, a lot of people use GitHub Actions as well. What is your approach today to ensure that it's not that hard to switch the pipelining tool?
Yeah, that is exactly what I wanted to say. We try to move detail that we need for the build out of the pipeline description. So like we move the detail out of our core domain into the adapters layer, we thought of how can we move the detail of what is going on in the pipeline out of the pipeline step. For example, we moved in one project from GitLab to code pipeline to GitHub Actions back to GitLab. So quite a lot of moving. And one thing, for example, if you have a build step, and that is multiple CLI commands, you don't put it in the pipeline description. You have a local script where you put all the steps you need for build, and then you run that script out of your pipeline. So when you now need to change from a GitLab CI YAML to a GitHub Actions YAML file, then you just move one line. Now, it's a little bit more, of course, you need the whole structure and all that. But the actual detail, right, that you need to execute is encapsulated in a script. So in some scripts, there's Bash, and others, they use Python for that. So whatever is the most convenient for the actual team. Same for testing, same for packaging, same for pushing it to S3. Make sure the actual pipeline the pipeline description file does not have too much knowledge. So it's structure, it's triggering behavior, but the actual behavior goes outside. That is the approach we use so far. Others are maybe in the serverless CDK things, just use common software engineering techniques, right, to make it modular and use abstractions and stuff like that. But most of it move the details out.
Cool. So that means that you're taking most of the pipeline, most of the build steps and things like that into shell commands that can then be used across multiple different pipeline instantiations, right? So this could be moving from different pipeline vendors to another one. And I think that's the approach that a lot of people are taking. Thorsten, who is another DevTools hero, has been working on ProGen pipelines as an alternative to using a shell-based approach. I will link the project in the show notes as well. This might be a good option for you to look at as well if you regularly need to switch between different pipeline systems. Okay, Maik, thank you. This was great. Let's look at a little bit what the key takeaways are of today. Maybe you want to get a first take at that, and then I can try to iterate on that. So what are the key takeaways out of the last 25 minutes?
So yeah, I would say one of the most important thoughts in source code, in your code architecture and in your pipeline architecture is think about which change would hurt me the most. So don't think about what change may come, think about what change are you most afraid of. And then be defensive about it by moving detail to something else so that you can decouple stuff.
Cool. So, okay, my key takeaways are you need to think about evolutionary architecture when you get started. That means you need to start to think about what the boundaries would be to change. That's the first one. The second thing is think wisely around the used deployment model in your projects and think about how the deployment pipeline for that looks like. As we also mentioned, this time and speed to deploy is a key point in all of the modern cloud development world today. And last but not least, have the concept of one-way versus two-way doors in your head. Whether you build services, whether you build pipeline, whatever you do in your projects, it's always good to know what is the impact of reverting a decision that you're taking, because that's going to be a key thing. And in the example project that we looked at, I think this was well thought out before we actually started. So I think we really did that, and that was an important thing. Cool. Maik, where can other people find you, reach out if they have questions? So I will obviously link in the show notes the link to the project that we showcased. Maybe you can get the diagrams that we looked at in as well. While I was looking at preparation, there is no pipeline in the project yet. Maybe I can force you to add a pipeline. But where can people ask you some questions if they have?
So the easiest way is to look me up at LinkedIn. So also maybe we can add the LinkedIn. I think also it is connected in my GitHub profile. So that's the easiest way.
Cool. If they want to work together with you somehow, there is obviously also a company page where they can reach out to. But this session was mainly done because you're an AWS community builder, and that's how you and I met. All right. So if you're interested to become a community builder, there is a yearly sign-up process that starts in January. And feel free to reach out to me or to Maik if you have questions on how to apply to become a community builder, because that's a great chance to make connections like Maik and I have. Right. And I think I wanted to thank you for being on the show, Maik, for preparing most of this. You said we prepared. That's a lie. You prepared, and was great to do this with you. And I hope that if you listened to this until the end, you enjoyed this part of this presentation and the details that we shared. Let us know if you're interested in more similar topics, and then we can see what we can bring to you. Maik, thank you so much. Have a great rest of your day.
Bye-bye.